preparing for this journey.
You are go for TLI, over.
Collins, 37, a West Point graduate and career test pilot, will fly the command module around the moon. Aldrin, 38, also from West Point with a doctorate from MIT, will join the 37-year-old Armstrong, NASA's only civilian astronaut, in the first attempt to land on the moon.
Looks like it's going to be impossible to get away from the fact that you guys are dominating all the news back here. Even Pravda in Russia is headlining the mission and calls Neil the czar of the ship.
4 days and 250,000 miles from Earth, the crew enters lunar orbit.
You are go for LOI, over.
Roger. Go for LOI.
All your systems are looking good.
Everything looks okay up here.
Going around the corner, we'll see you on the other side, over.
Going through my mind was a very simple equation in here. Today, we're either going to land, we're going to abort, or we're going to crash.
Okay, all flight controllers, gonna go for landing. Retro. Go. Righto. Go. Guide. Go. Control.
70 miles above the moon, Armstrong and Aldrin undock the LEM and begin their descent.
Capcom, we're go for landing.
In Houston, 26-year-old Steve Bales, in charge of guidance control, anxiously awaits data to track their speed and location.
When we finally get data, I realize that we're going toward the moon 13 miles an hour faster than we should be, and the computer doesn't know it, and our ground radars tell us. And that doesn't sound like much, and yet it's almost enough that we have to abort the mission.
My trench comes up and says, hey, we're not in the position that we expect to be. We've got some velocity errors, and the one that really got your attention, we're halfway to our abort limits. So, holy cow, things are mounting in here.
City Ag, 47 degrees.
We have a rule that says if it gets up to 20 miles an hour, we're going to stop this mission because you could actually literally crash into the moon and not know it, or you're on automatic pilot.
Their velocity stays within acceptable limits, but the trouble is far from over. In the lunar module, Neil Armstrong realizes they have overshot their intended landing site.
Maybe 3 or 4 minutes into the descent, Neil made an observation that looks like we may be a little bit long. And I thought, geez, you know, how can he possibly suspect that? But it turned out that we were a little bit long.
Only when the LEM pitches over to prepare for landing can Armstrong get a good look at the surface below, out the pilot's window. They're heading down into a field of boulders. He hits the throttle, hard.
I see the vehicle going across the surface of the moon like I have never seen it do in simulations. And I say, what has gone wrong? What's going on? It's going 5 times as fast horizontally. It's never supposed to do that. It's just supposed to gently hover down it.
100 feet, 3.5 down, 9 forward.
We knew that they were not landing where they're supposed to land. We worked on the exact landing point for so long, and we wanted this landing specifically to be very successful and safe. And here they are, not landing where they're supposed to be, and we have no idea where they will finally land. And it was really terrifying to find out that perhaps here we're going to see something that might end the program.
With a minute to go, they confront the unthinkable, an abort or even a crash. Armstrong's search for a good landing spot is using up precious fuel.
60 seconds. Lights on, forward.
And then when 60 seconds and the light came on, and we were still not real close to the ground, we were maybe 100, 120 feet, then I guess I was getting a little concerned, but what could I do? Could I say, hey, Neil, hurry up, get it on the ground? That would just excite him a little bit more, so I couldn't say that.
Armstrong has flown 4 miles past the prime landing target. He has half a minute's worth of fuel left.
30 seconds.
You hear 60 seconds, and you hear 30 seconds. And we ever get to 0, we're going to call an abort on fuel, and the crew knows it, and we know it.
And about the time we got 30-second call, the crew said, hey, we're kicking up some dust.
Picking up some dust. Okay, 75 feet.
And we knew then that we were close. And there, I knew that no matter what I would say or do from now on, this crew was going to go in for the landing.
4 forward, drift into the right level.
So we just shut up here in the ground, and all we were doing was letting them know what their fuel status was.
And the fuel is going lower and lower. And then finally you hear contact light.
Contact light. Okay, engine stop. We copy you down, Eagle.
Then he says something I will never forget.
Houston, Tranquility Base here. The Eagle has landed.
I didn't know what Tranquility Base was. They have never used that term when we were doing simulations. They always called themselves Eagle. So, what is this, Tranquility Base? And then I think, what a wonderful name. I mean, all that in a matter of 2 seconds.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
Gene Kranz has no time to catch his breath. He must quickly decide. Is the spacecraft safe where it stands? Or should the crew launch from the lunar surface immediately to rejoin the command module?
We had to look over the spacecraft very quickly, make sure the spacecraft was safe, it wasn't toppling over, we hadn't damaged any of the fuel systems by blowing rocks maybe up into the lunar debris, up into the soft underside of the spacecraft. So I had to do this very quickly.
And after about 2 minutes, then it's too late, really, because if you were to lift off after 2 minutes after the normal landing, Mike Collins is going round and round, and he's too far ahead for you to catch up to him in a reasonable time.
And I just couldn't get the words out to start the stay, no stay process. And in frustration, after a couple seconds, I wrapped my right arm on the console, and I had a pencil in my hand. I broke the pencil in two, and then got over that. It was just pure frustration. Got through it and got on with the stay, no stay decisions until we could finally get off shift and say, my God, today we landed on the moon.
And all of a sudden, the motions of everybody came through. They all got up and clapped. Von Braun was sitting right in front of me. He turned to me and with an OK sign, he said, "Thank you, John. That's the biggest compliment I've had in my life."
That's one small step for man, one giant leap for mankind.
The most massive and concentrated effort of science and engineering since the building of the atomic bomb has paid off. The cost has been high, $20 billion, and the lives of 10 astronauts, Soviet and American. But on July 20th, 1969, only 8 years after President Kennedy committed the nation to the challenge, Neil Armstrong and Buzz Aldrin walked the surface of the moon. But what is this place they've landed on? This moon that is bigger and closer to its host planet than any other moon in our solar system. What can we learn by actually being there? About its age, its origins, its crater-torn surface. The focus of Apollo is about to change. Armstrong and Aldrin bring back precious samples from the moon that are immediately sealed away in airtight vaults. The first pieces of another world.
I was a scientist at the U.S. Geological Survey at the time, one of those chosen to study the samples, and it's 30 years ago now, but I can remember the excitement of coming here and getting our bits of material.
When the rocks first came back, it was really amazing because the rocks Neil Armstrong picked up turned out to be basalts, and the ages of those weren't a few thousand or hundreds of thousands of years, but were 3.7 billion years old, older than virtually all rocks we'd found on the Earth at that time.
Basalts like this are made from cooling lava, the holes from bubbles of escaping gas. On Earth, basalts are relatively young,